Yes, you can add an extension ring to an existing electrical box solely to increase the volume of the box for conductor fill. This practice is permitted by the National Electrical Code, or NEC, provided that you adhere to specific guidelines and requirements to ensure a safe and compliant electrical installation. The primary reason for using an extension ring is to provide adequate space within the electrical box for all the conductors, devices like switches and receptacles, and any necessary wiring, connectors or splices. The NEC specifies fill requirements for electrical boxes to prevent overcrowding, which can lead to overheating, insulation damage, and potential electrical hazards. Calculating the correct box fill involves determining the total volume occupied by all conductors, devices, and fittings within the box, and comparing that to the maximum allowable volume for the specific box size and type. Extension rings effectively increase the usable volume of the box, allowing you to accommodate more conductors or larger devices. When adding an extension ring, it is crucial to ensure that the ring is properly listed and labeled for its intended use. The listing should indicate that the extension ring is suitable for use with the specific type of electrical box to which it will be attached. This ensures compatibility and maintains the integrity of the overall enclosure. Furthermore, the extension ring must be securely attached to the existing electrical box to provide a rigid and reliable connection. This typically involves using screws or other appropriate fasteners to create a mechanical bond between the ring and the box. The connection should be robust enough to withstand normal handling and vibration without loosening or separating. In addition to the mechanical attachment, it is essential to maintain proper grounding continuity when using an extension ring. Grounding ensures that all metallic parts of the electrical system are connected to a common ground, providing a path for fault current to flow back to the source in the event of a short circuit. This helps to trip the circuit breaker or fuse, de-energizing the circuit and preventing electrical shock hazards. When installing an extension ring, you must ensure that the grounding conductor is properly connected to both the original electrical box and the extension ring. This may involve using grounding screws, bonding jumpers, or other approved methods to create a continuous grounding path. The NEC provides detailed guidelines for calculating box fill in Article 314.16. This section specifies the allowable number of conductors, devices, and fittings that can be installed in an electrical box based on its volume and the size of the conductors. The calculation involves assigning a volume allowance to each component within the box. For example, each conductor that originates outside the box and terminates inside the box counts as one conductor. Conductors that pass through the box without being spliced or terminated count as one conductor as well. Each device, such as a switch or receptacle, counts as two conductors, and any fittings or wiring connectors also have a corresponding volume allowance. To determine the total volume occupied by these components, you need to consult the NEC tables that provide the volume allowance for different conductor sizes and device types. These tables are typically found in Article 314.16 of the NEC. Once you have calculated the total volume, you can compare it to the maximum allowable volume for the electrical box and extension ring combination. A maximum allowable volume is typically marked on the electrical box and extension ring, or it can be determined based on the box dimensions and the NEC guidelines. If the total volume exceeds the maximum allowable volume, you will need to either reduce the number of conductors or devices, or use a larger electrical box or extension ring to provide adequate space. It is important to note that the NEC also specifies requirements for the arrangement and support of conductors within the electrical box. Conductors should be neatly arranged and bundled together to minimize the risk of damage or insulation breakdown. They should also be supported in a way that prevents them from pulling on the terminals of devices or creating excessive strain on the connections. In addition, the NEC may require the use of cable clamps or other strain relief devices to secure the cables entering the electrical box and prevent them from being pulled out. Furthermore, when adding an extension ring, you must consider the accessibility of the wiring and devices within the box. The NEC requires that all electrical connections and devices be readily accessible for inspection, maintenance, and repair. This means that the extension ring should not obstruct access to the wiring or devices, and it should be possible to remove the extension ring without damaging the wiring or devices. In some cases, it may be necessary to use a special type of extension ring that provides a hinged or removable cover to allow access to the wiring and devices. In addition to the NEC requirements, local electrical codes and regulations may also apply to the installation of extension rings. These local codes may have additional requirements or restrictions that you need to be aware of. It is always a good idea to check with your local electrical inspector or building department to ensure that your installation complies with all applicable codes and regulations. One important aspect to consider when adding an extension ring is the potential impact on the structural integrity of the electrical box and its mounting. Electrical boxes are typically designed to be mounted securely to a wall, ceiling, or other structural member. The addition of an extension ring can increase the weight and size of the box, potentially putting additional strain on the mounting. Therefore, it is essential to ensure that the mounting is adequate to support the added weight and size of the box and extension ring combination. This may involve using larger or more robust mounting hardware, or reinforcing the mounting surface to provide additional support. Another factor to consider is the environmental conditions in which the electrical box and extension ring will be installed. If the box is located in a damp or wet environment, it is important to use a weatherproof extension ring that is designed to protect the wiring and devices from moisture. Weatherproof extension rings typically have a gasket or seal that prevents water from entering the box. Similarly, if the box is located in a corrosive environment, it is important to use an extension ring that is made of a corrosion-resistant material such as stainless steel or aluminum. In some cases, it may be necessary to use a combination of different types of extension rings to achieve the desired box fill and accessibility. For example, you might use a shallow extension ring to provide a small increase in volume, and then use a deeper extension ring with a hinged cover to provide access to the wiring and devices. The key is to carefully plan the installation and select the appropriate extension rings to meet the specific requirements of the application. When working with electrical wiring and devices, it is always important to follow safe work practices and use appropriate personal protective equipment, or PPE. This includes wearing safety glasses, gloves, and other protective gear to prevent electrical shock, burns, and other injuries. It is also important to energize the circuit before working on any electrical wiring or devices. This can be done by turning off the circuit breaker or fuse that supplies power to the circuit. Before beginning work, it is always a good idea to test the circuit to ensure that it is de-energized. This can be done using a voltage tester or multimeter. In summary, adding an extension ring to an existing electrical box can be a useful way to increase the volume of the box and accommodate more conductors or devices. However, it is important to follow all applicable NEC requirements, local codes, and safe work practices to ensure a safe and compliant installation. This includes selecting the appropriate extension ring, properly attaching it to the electrical box, maintaining grounding continuity, calculating box fill, and ensuring accessibility to the wiring and devices. Furthermore, it is important to consider the structural integrity of the mounting, the environmental conditions, and the potential need for a combination of different types of extension rings. By carefully planning the installation and following all applicable guidelines, you can safely and effectively use extension rings to enhance the functionality and safety of your electrical system. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. To reiterate the key points, firstly, extension rings are permitted by the NEC to increase box volume for conductor fill. Secondly, ensure the extension ring is listed and labeled for the intended use. Thirdly, securely attach the extension ring to the existing electrical box. Fourthly, maintain proper grounding continuity. Fifthly, calculate box fill according to NEC Article 314.16. Sixthly, arrange and support conductors neatly within the box. Seventhly, ensure accessibility to wiring and devices. Eighthly, consider the structural integrity of the mounting. Ninthly, account for environmental conditions. Tenthly, use appropriate personal protective equipment and safe work practices.